Now that we have talked about all of these different algorithms, let's review the analysis for each one. Every algorithm has a best, average, and worst case scenario. For each of the searches and sorts that we talked about, we discussed these three. Let's just review them all so that you can kind of get a big picture idea of this whole algorithm's analysis process. Let's start with the linear search. Remember, the best case scenario for the linear search was when it was the first element that you're looking at and you found it. It only takes one step. Doesn't matter the size of the list. The average and worst case are when the value is somewhere in the middle of the list or at the end of the list or not even there. For the binary search, O of 1 is the best case scenario because that's the first item you look at, the very middle item. If it's the middle item, you have found it and you're done. Otherwise, it's somewhere in the middle of the list and you find it in log n steps. Or it's not even there and you discover that in log n steps. Remember the dictionary search that we talked about, as well as the array process that we examined in the video. These next three sorts are all called quadratic sorts because they're all n squared. The nature of the sorts are a loop inside of a loop. They all have running times of n squared. The selection sort has the loop inside of the loop. Remember where the queen is trying to find the best value for the king, and she goes through the list every single time. The bubble sort is when the king is going through comparing next door neighbors and swapping every time they're out of order until he gets a clear pass. The insertion sort is when the king is looking down the list and shoveling the values down the way, shifting values across until every value has found its best position. All three of these sorts are quadratic sorts. The nature is a loop inside of a loop. The difference is for the bubble and the insertion, the best case scenario is when the list is already in order. It only takes one pass for the bubble sort as well as one pass for the insertion sort, and we're done. So both of those sorts are good for verifying that a list is in order. The final two sorts were n log n sorts all across the board. That basically meant there was a divide and conquer process. The merge sort divided the list, and then started merging them back into larger and larger lists until the whole list was sorted. It's n log n regardless of the nature of the data. The quick sort is also n log n because it uses the partitioning process using the pivot. It gets values on either side of the pivot, and as long as it's fairly balanced with a little bit of distortion on either side, it's a pretty good algorithm. When it's totally unbalanced, it becomes an n squared sort because all of the values end up on one side of the partition and not the other. You need to understand how all of these work, what the running times are, and why, and just have a pretty good understanding of the nature of all of these algorithms.